Hello everyone, myself Bhuvan Chandar, studying B Pharmacy first year in Maharaja College of Pharmacy. Today I am here to discuss with you catabolism of heme, degradation of heme to bile pigments. Erythrocytes have a lifespan of 120 days. These are taken up and degraded by macrophages of reticuloendothelium system in spleen and liver. Hemoglobin is cleaved into protein part globin and non-protein part heme. Per day, 6 grams of hemoglobin is breakdown in adult men and it is reutilized. Fate of globin. Globin may be reutilized as for the formation of hemoglobin or degraded to individual amino acids. Source of heme. About 80% of heme that is subjected for the degradation comes from the erythrocytes and rest from the immature RBC, myoglobin and cytochrome. Now coming to the pathway. When aged erythrocytes enters into the macrophages, hemoglobin is cleaved into heme non-protein part, globin protein part. Globin is reutilized or degraded. Heme with oxygen is converted into biliverdin in the presence of enzyme heme oxygenase. Here NADPH2 is utilized and converts into NADP plus. Ferrous ion in heme is oxidized into ferric ion and releases carbon monoxide also release. Biliverdin is converted into bilirubin in the presence of enzyme biliverdin reductase. Here NADPH2 is utilized and releases NADP plus. Bilirubin in macrophages is in unconjugate form. When unconjugate bilirubin enters into blood, it combines with albumin and forms albumin bilirubin complex. In blood, unconjugate bilirubin is converted into conjugate bilirubin. When it enters into liver, conjugate bilirubin reacts with UDP gluconate and converts into bilirubin digluconate in the presence of enzyme bilirubin gluconate transferase. Here, UDP glucuronate is utilized and releases UDP. When bilirubin diglucuronide enters into intestine or kidney, it converts into urobilinogen in the presence of enzyme microbial enzymes. Now, urobilinogen enters into kidney in the form of urobilin and it gives color to the urine. When urobilinogen enters into intestine in the presence of enzyme, microbial enzyme, it converts into stercobilin and it gives color to the fecus. Due to the deficiency of enzymes in this pathway leads to some metabolic disorders. They are hyperbilirubinemia. It is the condition in which there is a elevated levels of bilirubin in blood by which the deficiency of bilirubin glucuronide transferase leads to hyperbilirubinemia. During on the cause of the hyperbilirubinemia, jaundice may appear at birth or at time afterwards. Any obstruction in this pathway leads to hyperbilirubinemia. Symptoms of hyperbilirubinemia: lethargy, yellow coloring of skin and eyes. Diagnosis of hyperbilirubinemia: direct and indirect bilirubin levels, red blood cells count. Treatment of hyperbilirubinemia: phototherapy, fibrotic blanket. Conclusion of this topic is heme catabolic pathway is considered to play an important regulatory role in cell protection, apoptosis, inflammation, and other physiological and pathological process. The end product formed by the catabolism of heme is bilirubin. I refer this topic from Biochemistry by U. Satyanarayana and U. Chakrapani. Thank you.